You can give reply in the chat window. Okay. So today, everyone has a notebook and pen, no? You have to note down now whatever problems we are going to solve from today. Everyone must have a notebook and pen with you. Otherwise, this subject you will not understand. You need to solve problems. Yes, everyone has notebook and pen, no? Reply in the chat window. At any time, I will ask you to share your notebook. Huh? Okay. So, shall we start now? Let us start with our unit number 1. Whatever basics needed for that, for this subject, that we have already covered in last 2 lectures. Okay. So, let us start with the formal language and automata theory. Okay. So, what we have seen last time, what is mean by a symbol? Okay. Is this visible? This font size? Okay. Is this visible now? Okay. So you can note down. So what is mean by a symbol? Symbol is a what any user defined entity. Okay. So last time we have seen symbol is any user defined entity. It can be digit, it can be alphabet, anything defined by the user. It is the basic unit of a language. So let me check. So it is the basic unit of a language. So it can be digit, it can be alphabet, it can be anything. It can be like I'm considering this object, fruit. So symbol is anything that is defined by the user. Okay. So that is the first terminology. The next terminology is what? Alphabet. You can note down these examples also. So what is the alphabet? So alphabet is denoted by this summation notation. So alphabet is a what? It is a finite set of symbols. Okay. So let I am considering alphabet as a digits. Okay. So digits. So this is the alphabet. What? It consists of the finite set of digits 0 to 9. Your alphabet, it can be the small case letter or uppercase letter. Okay. So alphabet is a what? But it is a finite. It is a finite set of symbols. Okay. So after symbol, alphabet, next definition is what? String. Okay. So what is a string? String is a what? It is a finite sequence of symbols from some alphabet. Okay. So for example, if my alphabet is let A comma B comma C. So the strings that can be formed using A, B, or C. Okay. But it is a what? It is a finite sequence of symbols from some alphabet. So you can form a string like AAB, or it can be ABC, or it can be BAC. Okay. So all these are what the strings for from this alphabet. Okay. Now let us define what is mean by a proper, what is mean by a prefix. Okay. So prefix is what? Note down the definition. Prefix is obtained by removing.
It is not visible properly.
Yes,
Ma'am, your screen is not visible properly.
but it is visible for me. No, I have started from 2 devices. On laptop, I can see it. Just check. Oh, let me check. Oh,
No, ma'am, it is not visible.
array. So what is the problem? Just wait. Is it visible now? Just wait. Is it visible? Still, just a minute. Okay, so please note down again. Let me check what can be done because it is visible from my laptop. Okay, use switch camera in Meet. What are the how to do it? Because I have logged in using two devices, mobile and laptop. So from my mobile, I'm taking this lecture. Let me check where is that option.
Ma'am, turning on video and then switching camera.
In Google Meet, where is that option? Okay, switch camera. Then the same thing it is, no? No, it's the same way. Are there any students in the waiting room? Please wait, let me start again. Yes, switch camera. After that, where is that option?
You need, ma'am, you need to turn on the video firstly.
Well, on video. Okay. No, first you have to on the video and then. So once you start presenting, you cannot switch on the camera, no? That message I am getting. Okay. So let me first start. Okay. Then, okay. Is this visible now? Not clear. Okay. Mm, the same way I did now, you said, no? Is it visible? Mhm, mhm. If visible, shall I continue now? Okay.
Yes, ma'am, continue.
Now it is visible, na? Okay. So, ये note down किया आप लोगों ने? What is the symbol? Symbol is a user-defined entity, anything that is defined by the user. And alphabet is what? Finite set of symbols. And string is a what? It is a finite sequence of symbols from some alphabet. Okay. So now next we are considering what? Prefix. Okay. So note down please. Prefix, it is obtained by removing zero or more symbols from the ending of the string. Okay. So empty string is denoted by the epsilon. Okay. So prefix, suppose given the string ABC, okay, and we have to find prefixes of it. It is obtained by removing what? Zero or more symbols from the ending of the string. Okay. So if I remove zero, zero means empty string, you will get what? ABC. Then if I remove C from this, you will get AB. If I remove BC from it, you will get A. And if I remove all three symbols ABC, you will get epsilon. Okay. So prefixes of the string ABC are what? ABC, AB, A, and epsilon. Okay. Is that clear? Okay. So and proper prefixes, it is proper prefixes is what? Prefixes other than the string itself. Okay. So proper prefixes of this is what? A, B, A, and epsilon. Okay. So is the prefixes clear? Okay. So we'll go for the next term. That is what? Suffix. Okay. So what is the suffix of a string? It is the opposite of the prefix. Okay. So if I give again the same string, let us consider suffix. It is obtained by removing zero or more symbols from the beginning of the string S. Okay. So if I remove here epsilon, so you will get ABC. If I remove A, you will get BC. If I remove AB, you will get C. And if I remove all the three leading symbols, then you will get the epsilon. Okay. So suffixes of this string ABC are what? ABC, BC, C and epsilon. Okay, so now if I give you the string, let us consider, if I give you the string, suppose D, E, G, H, can you find prefixes and suffixes of this? Find the prefixes of this, and once you finish, you tell me whether that is clear to you or not. Is that okay? Whenever I am writing at the same time, please note down all this. Okay. So can anybody tell me, unmute yourself and tell me the prefixes for this D, E, G, H? Yes, anyone?
DEGH,
Correct.
DEG,
Okay.
DE,
Yes.
D,
D.
epsilon.
Okay. Everyone clear how we got this? D, E prefixes, and proper prefixes are what? Prefixes other than the string itself. Okay, so other than this string, remaining are the proper prefixes. Similarly, find the suffixes of this string. Suffixes.
DEGH,
Yes.
EGH,
Yes.
EGH, GH,
Yes.
H,
And epsilon.
and
Okay. Correct. Okay, so this is what about proper prefixes, okay, and suffixes. Now the next terminology is what? Language. What is the language? Okay, so language is a what? It is a set of strings comprising symbols from one alphabet. Okay, so let phi indicates the null set, and empty string is denoted by the, here we have seen, epsilon. Okay, so if my input alphabet is suppose A, okay, the language notation is what? This summation closure. Okay, so this is the language notation. So the language defined over this input alphabet, it will contain what? Epsilon. So first you can note down all the strings of length 1, then you can note down the strings of length 2, then you can note down the strings of length 3. So like this way, this is what the language. Okay, so all of you note down what is a language. Language is defined as a set of strings comprising symbols from one alphabet. Okay, now, okay, so I'll give you one example. Suppose my input alphabet consists of two symbols, 0 and 1. Okay, suppose my input symbol consists of 0 and 1. Can you find the strings for this language? Is the question clear? If my input alphabet consists of 0 and 1 symbols, can you find here? Yes. So what are the strings in this language? First, you have to note down what? Epsilon. Then from this alphabet, strings of length 1. So strings of length that you can form is what? 0 or 1. Then you have to note down the strings of length 2 that you can form from this symbols of the alphabet. So from 0 and 1, the strings that you can form is, it can be 0, 0, it can be 0, 1, it can be 1, 0, it can be 1, 1. Okay, so after noting the lengths, strings of length 2, you can note down the strings of length 3. So like this way. So can you note down? Can you complete this? Can you note down? And this is infinite. So dot dot dot, and this completes what this language. Okay, so is that clear? So what this is a language? It is a language of zeros and all the strings of the zeros and ones. Okay, so is the language definition clear to you? Okay. Yes or no, you please type it in the chat window so that I can continue. I can move to the next. Okay. So formal. So this is what a formal language. So this notation is what language. If I remove epsilon from this, you can note by this notation. Okay, summation, positive, closure. If I remove the epsilon from this, so this is how you can note down for this. Okay, so this is a minimal form of the formal language. So the word formal refers to the fact that all the rules of the language are explicitly stated in terms of the possible strings of the symbol that can occur. Okay, and the valid sentence forms. Okay, so this is a formal language. Okay, we are expressing it in terms of the possible strings of symbols. Okay. In other words, what? The semantics. Semantics is what? Meaning of any statement in a formal language is directed by the syntax of the statement. Okay. So a formal language is considered as symbols on paper and not an expressions of ideas as in natural languages like English. Okay. So we know that in natural languages, what? A single statement might mean different things when altered differently and in different situations. However, in formal language, what? Any statement always has the same meaning. Okay. All we know that all programming languages are the formal languages. Its meaning is not changed based on the situation. Okay. So now we'll start with this basics. Now we'll start with the, now we have already seen the what is mean by a set, relations, function, graph theory, okay, trees. Okay, so what is a finite state machine? So finite, as the name indicate, finite, there will be finite number of states. So machine mean here is what? Machine is any predictable program whose behavior can be understood without executing them. Okay, so finite state machine, it is used for all such programs that have a finite number of functions but do not have any memory for storing the intermediate results. Okay, it has a limited power due to lack of memory. It is a simple and primitive computational model. So you can note down some of the points about this finite state machine. Are you noting down? Shall I repeat? Shall I repeat about finite state machine? Okay. So finite state machine is a what? It is used for all programs that have a finite number of functions. Note down it. It is used for all programs that have finite number of functions but do not have any memory for storing the intermediate results. It do not have a memory for storing the intermediate results. It is a simple and primitive computational model. First, we are starting with what? Simple model, which has many applications but limited power due to lack of memory. Due to lack of memory. So what is the meaning of machine here? So finite state, it means finite number of states, and state here is referred as a what? It is used for different functions that are the constituents of a program. Okay, so state means, state refers to the functions and machine refers to a program. Is that clear now? Again, I'm telling it is not anything hardware or any machine actually. Okay, so machine means in this subject, what is it? Machine is a program. And state is a what? Functions. Okay. So machine refers to a programs whose behavior can be understood without executing them. Is it clear now, machine and state meaning? Okay, so machine is a program whose behavior we can understood without executing them. Okay, so first, before considering finite state machine, let us start with the basic machine. Okay, so what is a basic machine? So as we know that ideally what a machine takes an input and produces an output. Okay, write down about basic machine. A basic machine recognizes an input from an input set and produces an output from an output set. Okay, so we are considering input set as a I and output set as a O. Okay, so I here is a what? I is a set of, let me check, as some students are saying the screen is not clear. Okay, so is it clear now? Just note down. Okay, let me check. So I'm not doing anything, I'm not moving, but why still it is not clear, I don't know. Is it now? So I here I have used as a what? As a input set, and O is used as a output set. Okay, so please you need to concentrate on this because the screen problem I know it is getting in between. Okay, so okay, so in basic machine is a what? Where we are giving the input and it is producing some output. And here we are not interested what is happening inside. We are just interested what is the output. What is the output for the given input? Okay, so basic machine just consists of two sets, input set and the output set. Okay, so we'll give the input from the input set and we'll get the output from the output set. Okay, so here we'll use a one machine function. Note down. Machine function is what? MAF. What we have written? Machine function is a MAF. And here the machine function is what? I. This is how we'll denote the function. It takes the input from the input set and produces the output. Okay. So we are not getting here what is happening inside this. Okay. So if you consider simple basic machine, suppose AND gate. Okay. So what is the input set for the AND gate? So we are giving a pair here, let 0, 0. We know that 0, 1 or 1, 0 or 1, 1. Okay. So if this is my input, what is the output corresponding generated? We know. So output here, it can be either 0 or 1. Okay, so this is a basic machine. You know that if you give the output as a 0, 0, sorry, if you give the input as a 0, 0, what is the output? 0. If you give the input as a 0, 1, output is again a 0. Okay, so here the machine function you can write here like this way: input, output. Uh, so if I give the input as a 0, 0, what is the output generated? 0. If I give the input as a 0, 1, what is the output generated? 0. If I give the input as a 1, 0, output generated is what? 0. If I give the input as a 1, 1, the output generated is what? 1, 1. Okay, sorry, 1. So this is a what? This is a machine function for the AND gate. Okay, now you solve one thing. Write the machine function for the OR gate. Can you write the machine function for the OR gate? Can you write the machine function for the OR gate? Okay, so you solve that problem. So write the machine function for the OR gate. So this is a one example. Another example is what? Decimal to binary converter. Okay, where you are giving the input as a decimal number and you are getting the output as a what? Binary number. So that is a one example of the basic machine. Another example you can consider as a what? Weighing machine. Okay, generally we see that at railway station or bus stands. Okay, so that is again a good example of a basic machine where the output is the what? Weight ticket, which is obtained after inserting a coin. Okay, so input is a what? Coin, and the output is a what? Printed weight ticket. So that can be one example. Can anybody tell me any other example of the basic machine where you are giving the input and you are getting the output, but you are not knowing what is happening inside it? Can anybody give the example? Is the basic machine clear? Is the basic machine clear so that we can move for the finite state machine? Okay, so if that is, let me adjust first. So we'll take the what? Finite state machine. Okay. So difference between the basic machine and finite state machine is what? Basic machine just takes the input and produces the output. It has two sets: input set, which is a finite set of input symbols, and output set, which is a finite set of output symbols. Okay. So let us now consider the finite state machine. Okay. So in the finite state machine, okay, this machine it has some internal states. As the name indicates, state, it has some internal states. Finite state machine is represented by a pair of functions. There are two functions: machine function and the state transition function. Okay, so machine function, it is, again we'll use the same name, MAF. Okay, so machine function is a what? MAF. Okay, and here it takes input from the input symbol, and it take the input as a what? State from this S. S is a what? Finite set of states. I is a finite set of input symbols, and then it produces the output. Okay, so there are three sets now, correct? I, S, and the O. Please note down the meaning of this I, S, and O, where I is a what? It is a finite set of input symbols. I is a finite set of input symbols. S is a finite set of internal states of the machine. And O is a finite set of output symbols or the output alphabet. So have you noted this? So that we'll consider the example. And let us design the finite state machine to construct a, note down, to construct a binary adder. So to construct a binary adder. Okay. So can now before you start designing this, you have to design consider what will be your input set, what will be your S, and what will be your O. Okay. So what will be your input set? Can anybody tell me what will be there in the input set? Binary adder. Binary adder may what will be the input sets? Okay, so 0, 1, but binary adder may we have to give the input as a pair, no? Either you suppose I give the okay, let me clear here. 0, suppose my input is 0, 1, 0, and so this is a one number, and to that we want to add suppose 1, 1, 0, 1. Okay. So input क्या हो सकते हैं in this? Either it can be 1 1 or 0 0. Yeah, that is correct. Piyush, your answer is correct. So your input can be 0 0. You can perform the addition of binary adder में 0 0 or 0 1 or 1 0 or 1 1. Okay, so this is your input set. And output set. Output can be what? Output can be 0 or 1. Okay. Now states we have to decide. Okay. So state means what? You know that whenever you add 1 plus 1, the output here is what? 0, and it generates a carry. Correct? So state here we'll consider two states, carry state and no carry state. Okay. Are the three sets clear? How we got this? Input set, output set, and the two states, carry and the no carry. Okay. So if I give the input, the same example, let us consider 0, 1, 0, 1, and to that we want to add 1, 1, 0, 1. And your initial state is that no carry. No carry means if I add 1 plus 1, you know that in binary addition, you have to also add the carry to it. So 1 plus 1 and carry is a no carry. So it is a 0. And what is the carry is generated here? Okay, so let's see is a carry. So 0 plus carry is 1 means this is a 1, and the next state generated is a what? No carry. Okay, so we'll add what? 1 plus 1, that is a, and no carry means 0, so 0, and here the carry is generated. So 0 plus 1 plus carry is what? 0, and the carry, finally what? The carry is generated. Okay, so we have to consider input as a what? This one of this input 0 0 0 1 1 0 and 1 1, and we have to explore all the possibilities from each state carry and the no carry for the given input. Okay, so how to write two functions now? First we'll write machine function. At the same time you can also note down the state function. So in the machine function, label your rows by input set, label your column by the states. Okay. So here the input consists of the four pairs 0 0 0 1 1 0 and the 1 1. Okay, and your states are what? Carry and the no carry. This is a one table. Okay, same way prepare state function table. It maps what? Input and state to the carry. So states, so again it will contain the four rows for the four input pairs, and now you have to fill these entries. Okay. Now can somebody tell me what in the machine function you have to fill these entries with the what? Output symbol, and in the state STF, that is state transition function, you have to note it with the transition or the state. Okay, so if my input is a 0 0 and current state is carry, can you tell me the output and the next state, so that simultaneously we can fill in the machine function table as well as state transition function table? Yes. Suppose my input is 0 0 and my state is carry. So what entry here it is, what is the output? Output is 1 and next state is what? What is the next state? Output is 1, that is correct. So 0 plus carry. So output is 1 and next state here in the state transition function, what is the next state? How it is carry? Hmm? So 0 plus C, 0 plus 0 plus carry. So what is it? 0 carry means actually it is 1. So 0 plus 0 plus 1. Is any carry generated here? Is any carry generated here? No. So it is a no carry. So we'll fill in the state transition function as a no carry. Simultaneously, can you fill the remaining entries? If my current input is 0 0 now, one by one you fill this. If my current input is 0 0 and the current state is no carry, so what is the output of this and what is the next state? Okay, so 0 plus no carry is what? 0, and there is no carry generated. So the state remains no carry. Is that clear? Can you fill the remaining entries and tell me? Please complete the remaining table. Who will tell me the entry for 0 1 and the current state carry? What is the output and what is the next state? Yes, that is correct, Bharat. 0 1 plus carry, output is 0 and the carry is generated, so the next state is carry. That is correct. Now I want to answer some from some other any other student. If my input is 0 1 and the current state is no carry, what is the output and next state? Input 0 1 plus no carry. What is the output? Yes, Atharva. Yes, 1 and no carry. That is correct. Now, next one. Fast, please tell me. 1 0 and the carry state. What is the output and the next state? 1 0 plus carry. Output is 0 and the carry is generated. That is correct. Next. 1 0 and no carry. What is the output? And next state? 1 0 and no carry. 1 0 and no carry. Output is 1 and the next state generated is no carry. That is correct. Now the last row, 1 1 and the carry. 1 1 and the carry. 1 and carry generated, correct? 1 1 and no carry. Fast, chalo. 1 1 and no carry. 0 and carry. Yeah, most of the students got the answer. So we completed this table. Is that clear how we got this? Is the example clear? A finite state machine for a binary adder. So now we'll consider the example, simulation of example. So how to show the simulation here? Okay, so suppose you want to add 1 0 1 1 and 1 1 1. So you want to perform the addition of this. Note down the here 1 0 1 1 plus 4 times 1. Okay, so you have to show the simulation like what? Current state. So you will make 4 columns. Listen, current state, then input, then next state, and then output. Make the 4 columns: current state, input, next state, out and output. So how will show the simulation? Let us consider. Okay, so our example is what? 1011 plus 111. As we know that machine will get the input from this one. First it will get correct 11. We'll start with the list significant digits. Okay, so the current state will always start machine with the which state? No carry. And now your current input is what? 11. So we know for the 11 and the current input state no carry, what is the next state generated? What is the next state generated? So for the no carry, inside bracket you can write 0. So the next state generated is a carry, and inside bracket you write 1. And what is the output generated? Output is a 0. Is it clear? Next state is carry and the output is 0. So next time, next pair we have to consider. We are considering this in this direction. Okay. So first we considered the least significant digits 1 1. Then next pair is 1 1. And now the next state becomes the current state for the next step. And now your current state is what? Carry. Inside bracket, let us write carry means 1. And now here in this example, our current input pair is also 1 1. So what this indicate? Now your current state is carry. Input is 1 1. So the next state is what? Carry. And the output is also 1. That is correct. Okay. So now next pair input is what? 0 1. So this carry, it becomes the current state now, C1. And now the input is what? 0 1. So what is the output on the next state? Okay. Output is what? And the next state is here. 0 1 plus carry. Is the carry generated? Yes, carry. And output here is 0. Again, one pair remains. So last now. So this C carry is the current state, and now input is 1 1. So what is the output? Output is 1, and the carry is also generated. Okay. So finally your output is what? What is the output? What is the addition of this? You are also considering carry. Carry means 1, and this in this direction you are going to write. So 1 0 1 0. Is that clear? Can you simulate any example? Can you write the simulation of any example? You take one example and simulate it now. Let 0 1 0 1 0 plus 1 1. Simulate this example. What is given? 0 1 0 1 0 plus first 0 1 0 1 0, and the second number is 1 1 0 0 1. Note down it, and you have to make the 4 columns: current state, input, next state, and the output. Can you write the simulation? Note down किया है नहीं? Simulation. Next time you show me the simulation. We'll move further. Answer anyway you can find it, but are you able to find now the At each step, what is the next state and what is the output? Answer, so you know that how to do the binary addition. Okay. So next, here we consider the representation. Note down, there are two ways to represent this. One, the already we have seen using the machine function and state transition function. Another representation is a transition graph. As the name indicate, in graph we know that graph is denoted by a pair v comma e, where v is the set of vertices and e is the set of edges. Now here v is a what? Vertices set is your state set. Okay. So vertices corresponds to the states of an FSM, and now I'll say FSM. Now you know the FSM is finite state machine, and the directed edges correspond to the transitions from one state to the another on reading the input symbol, which is written on the directed edge. Okay. So note down about transition graph. It is a directed graph. नोट डाउन कर रहे हैं ना आप लोग? Transition diagram or transition graph is a directed graph whose vertices correspond to the states of an FSM, and the directed edges corresponds to the transitions from one state to another on reading the input symbol. Okay. So for this example, okay, transition diagram or transition graph is a what? It is a directed graph whose vertices correspond to the states of an FSM, and the directed edges correspond to the transitions from one state to another. On reading the input symbol, which is written above the directed edge. See how it is to be drawn, then you will understand. Okay, so graph. Okay, so graph mein here there are two states, no carry and carry. Okay, so vertices, there are two vertices in this graph, no carry and the carry. And see, for this example, you have to also indicate which is your start state. So in this, you will be denoting what? Arrow to the start set, and on the edge you write start. Okay, so no carry is our start state. Okay, now you have to add the edges. Okay, so edges are what? Edges are the transitions from one state to another on reading the input symbol. So no carry. So if you start, what are the outgoing edges from the no carry? Okay, so no carry on 0 0, you will say, you will do that is edges to the same state. So input is 0 0 and output for that is what? 0. This is how you will label the edge. Each edge is labeled by input. Follow after input, give the arrow and then write the output for that. Okay, so no carry on 0 0 remains in the same state and the output is 0. Similarly, the other edges can be added. No carry if I get the input 0 1 and the output generated here is what? 1. In the no carry state, if you get the input as a what? 1 0, what is the output generated? 1 0, and no carry output is what? 1. And in the no carry state, if you get the input as a 1 1, your state is changed to the carry state. So 1 1 is my input In the no carry state, so output generated is what? 0, and the state is changed to the carry. Can you add the remaining edges from the carry state? Please add the remaining edges from the carry state. Can you tell me the edges from the carry state? Carry state, if you get the input as a 0, 0, and carry, you are in the carry state, the output is 1 and the state is changed to the no carry. For the remaining inputs, 0, 1. Okay. And if you are in the carry state, so 1 plus 1, you know the output is here what? 0, and the state remains carry state. Similarly, in the carry state, if you get the input as a 1, 0, output is what? 0. And in the carry state, if you get the input as a 1, 1, then output is 1 and the state also remains carry state. Okay. So this is another way. So instead of using state function, state transition function representations, MAF and STF, you can directly draw the transition graph. Okay, so it gives the information about the output symbol as well as the next state, if we know the current input and the current state. Okay, so it is easier to understand the working of a machine with the help of this diagram, rather than you have to look then two different function tables, MAF and STF. So is this clear? Is transition graph clear to you? So the another representation, one more representation is there for this, that is a transition matrix. Okay, so what is a transition matrix? Let us consider. So another way to represent this is what? Transition matrix. Now in the transition matrix, what? Rows and columns, these are labeled by the states from the set S, and along the intersection of the ith row and jth column, there is an input symbol from the input set, which causes the transition from the current state S I to the next state Sj. See what you have to do. So here the transition matrix for this is what? Rows indicates the current state, columns indicates the next state. Okay, write the full form. I have written here CS and the NS. So rows are labeled by the states, columns are also labeled by the states. Rows indicate what? Current state, columns indicates the next state. So states here are what? In this case, no carry and the carry. Next state also labeled by the pairs from the set. So as there are two states, this is a 2 by 2 matrix. Okay. So each entry, what you have to note, suppose this is my, okay. So at each entry, row means what? Your current state, okay. And the column is what? Next state, okay. So you have to add the entries which makes the transition from the current state to the next state for the given input symbol. So you know that if your current state is, no carry, is the matrix visible? No carry, carry. Okay, I'll tell you for the first entry, no carry to the no carry. So current state no carry, next state no carry. For which inputs you are getting this? So if my input is 0, 0, okay, and after that you write what slash and then write the output for that. Okay, so for the 0, 0 slash, oh, so what this indicate? Input slash output. Current state is no carry, next state is no carry. Okay, so this is one case. Another case, you use or for that. V indicates what? Or. So if your input is 0, 1, you are getting output as a what? 1, and the current state is no carry, next state is no carry. Similarly, or for what? 1, 0, and the output is 1. So like this way, you fill the all entries in this transition matrix. Okay. So if your row is ith row and column is jth row, then you have to consider what? The input symbol which causes the transition from SI state to the SJ. It is followed by the punctuation symbol slash and the output symbol from the output set O. Can you tell me the entries for no carry to carry state in the transition matrix? Yes, that is correct. No carry to carry, only one transition is there, 1, 1, and for that output is 0. That is correct. Now tell me the transitions from carry to no carry. What you will write in the transition matrix? Yes, that is correct. 0, 0, 1. Okay. Now carry to carry. We know that carry to carry, three inputs are there, 0, 1 slash 0 or 1, 0, output is 0 or 1, 1, output is what? 1. Okay, so this is another representation, that is what? Transition matrix. Okay, so here we completed one example and we completed the design of a finite state machine for the binary adder. Okay, so whatever we have seen, are those points clear to you? How to write MAF? Tomorrow I'm going to ask the questions on it. What is a finite state machine? What is a MAF? What is I? What is S? What is O? Okay, and how to draw the transition graph, how to write the transition matrix. Okay, so I'll give you one example for tomorrow's homework. Design a finite state machine. Note down it. Design a finite state machine for design a finite state machine for a divisibility by 2 for decimal numbers. Is the problem clear? Design an FSM for a divisibility by 2 for a decimal number. So what will be your, I'll just give you the hint and then you can solve. What will be your input set? You have to decide that I told you that decide your I, decide your O, that is the output set, and decide the S set of states. So your input is what? Can anybody tell me? Input क्या होगा आपका? Input is what? Input will be decimal numbers and it will be containing digits from 0 to 9. Okay, so input will be 0 to 9. What we want? Divisibility by 2. So if the number is divisible by 2, we'll produce the output as a 1. Otherwise, we'll generate the output as a 0. So you let your output consist of two symbols, 0 and 1. And now the states. So what you have to decide? States क्या होंगे आपके? You can consider two states. Let Q0 and Q1. Let Q0 is what? Divisible. You can consider. And Q1 is not divisible. With this hint, can you solve this problem now? Yes. Can you solve the problem? You have to write MAF, STF. You have to draw the transition graph. You have to also write the transition matrix. Consider any one example and try to simulate it. Can you do it or not? Input 0 to 9. So whether you will consider 10 columns? You just want the output as a what? Divisible or non-divisible. So further you can group input symbols. So we know that the 0, 2, 4, 6, 8, all these are what? All these are the divisible by 2 and remaining 1, 3, 5, 7 and 9. These are not divisible by. Can you try this now? So your inputs are now only two sets. Two inputs are there now. One is 0, 2, 4, 6 set. Other is with 1, 3, 5, 7, 9. Okay. So you can try that example. Or we'll discuss that in the next lecture. Yes, can you try? Yes, next time we'll see how the screen can be made more clear. I know that. Because on PPT it is not possible because the subject contains the problems that I already told.